Okay, so we've been focusing on solving percent problems the past few lessons, and today we're going to continue solving percent problems, but some that are slightly more challenging that require us to read very carefully to determine the parts for our equation. So we're going to go ahead and try one out. Corey and Everett have collected model cars since the third grade. Corey has 80 model cars in his collection, which is 25% more than Everett has. How many model cars does Everett have? Well, let's look back at the pieces given in this problem. Let's go ahead and take it sentence by sentence, reading really closely. So Corey and Everett have collected model cars since the third grade. That really doesn't tell me anything about the part, total, or percent, so let's move to the next sentence. Corey has 80 model cars in his collection. Well, what does that sound like? Well, it sounds like it could be a total, but let's go ahead and continue reading to see if we can confirm that this actually is a total. It then says that this is 25% more than whatever Everett has. Well, that sounds like a percent, but it actually is also saying that it's 25% more than somebody else. So let's just go ahead and highlight that so we can come back to it in just a second. And then the question is asking, how many model cars does Everett have? So that could be asking for the part or for the total. So this problem doesn't really give exact or clear parts, totals, or percents. So we do have a strategy that we learned a couple of lessons ago where we use a double number line to show what we have. So let's go ahead and draw out one for Corey and one for Everett. Okay, so we have a number line for Corey, we have a number line for Everett. We know they start at 0, and right now they'll be the exact same length. So let's go ahead and put in the information that we have. Well, we don't know how many model cars Everett has, so this number line goes from 0 to a question mark because we don't know the total. But we do know that Corey has 80 cars altogether, so this can go from 0 to 80. But apparently, his number line is actually 25% more than Corey's. So that means it's 25% longer. I'm sorry, not Corey, Everett is 25% longer than Everett. So let's go ahead and make this a little bit longer and show that this is 25% more than what Corey's number line is, and that is his total cars of 80. Okay, well, what percent would represent Everett's total cars then? Well, since we have 100% of whatever Everett's is, right, whatever his total amount. Oops, I'm writing the wrong person. Dang it, guys, sorry. This is Corey and this is Everett. I'm so sorry. So we also know that if whatever Everett's amount is, it is 100% of Everett's total, right? So if Corey is 25% more than that, that means if this is at 100%, right, the length of the number lines are the same. So if this is 100% and then he's 25% more than that, how are we going to find his percentage? Well, we would add these percents up. In fact, let me move it over a little bit. Sorry, my screen shifted. Plus 25% would give him a percentage of 125%. So let me write that here. That Corey's is 125%. So now it actually makes more sense if we look back at the question. It says that Corey is 25% more than what Everett has. So we need to add 25% to 100% of Everett's cars to get the actual percent we are using in the word problem. So we're going to label our percent, our quantity, and our whole. Remember, these are the pieces of our equation. But now we need to find out which one is the part and which one is the total. Well, if Corey's amount of cars is 125% of what Everett has, I remember that when we say percent of, that is giving me the total. Okay, so the percent of Everett's number of cars is actually the total we are looking to find. So we are looking for the total. So that is our question mark, right? The whole amount. So then if 125% of Everett's cars is 80 cars, so percent is, I remember that that tells us what the part is. So let's write that down in our notes. Remember, when we see the word of, that clues us to what the total is. When we talk about the percent is, that gives us the part. So 125% is 80. So then that is the part that they have given us, which means we are missing the total. Now, this is tricky, right? We had to break down a lot of what was going on from the problem to get those missing pieces. So we know that double number lines can be drawn out to show what we know to help find out what is missing. And then we can use our percent equation to solve. So let's go ahead and write that out. Quantity equals percent times whole. And we have the quantity is 80, the percent is 125%, but using Dr. P, we have to convert the percent to a decimal, which means that we are using 1.25 times whatever the whole amount is. Since we don't know it, we have to use our inverse operations to solve. And we are going to divide 1.25 into 80, but we know that we never divide by decimals, so that way we need to move our decimal point over 2 spots, both on the inside and on the outside. Oops, I was about to write it there again. So 125 into 8,000, and so we're going to draw our seats, and then we are going to start dividing. So I know 125 goes into 806 times. If I do some quick math, that's 750. 10, oh, that is 10 minus 5 is 5, and 7 minus 7 is 0, and then 125 into 500 is 2. Okay, and so we end up with 62. Oh, I'm sorry, that's 200. Whoops, 64, because 125 times 4, 28, 10, 500. So our whole number is 64. And if we look back up at the question, what does that mean? How many model cars does Everett have? Well, Everett has 64 model cars. Alrighty, so you're going to try another percent problem on your own, being very careful that when it says a percentage more than somebody else, that we have to add that percentage to 100%. So let's go ahead and try one on our own.